All right, so now we are going to talk about that quadratic formula. So this is a formula that sometimes when you get a quadratic equation to solve, factoring is going to be the easiest way. But they don't all factor. Sometimes the square root method will be the easiest way, but they will not all solve by the square root method. The only real positive thing I can say about the quadratic formula is that it does work every time. Sometimes when things just will not factor out or they won't solve in any other way, we have to go to the quadratic formula. Now remember, your quadratic equation, ax squared plus bx plus c equals 0. So my b is this negative b, and b squared. Whatever I have for a is here, and then c. Okay, so let's say that I have 3x squared minus 5x plus 1 equals 0. And it always has to be set equal to 0 for those to be in the right position. So I'm going to take a, b, and c. A negative 5 plus or minus the square root, negative 5 squared minus 4. 4 is part of the formula, so that will always be times 3 times 1. The whole thing. We've got a lot of people who will just put the 2a up under the radical here, but that's under the whole entire thing. 2 times 3. All right, so a negative 5 is a 5. Then we have 25 minus 4 times 3 times 1 is 12. So 5 plus or minus, remember we always have two solutions, the square root of 13 over 6. And if you're taking a test, I'm not sure, it will usually be plus or minus. Sometimes it'll be 5 plus the square root of 13 over 6, comma 5 minus the square root of 13 over 6. And don't forget, we had in previous examples where sometimes you can reduce all three. So check them and make sure. All right, so let's try another one. I have 2x squared minus 9x plus 10 equals 0. Okay. A, B, C. So again, I have negative 9 plus or minus the square root, negative 9 squared minus 4 times 2 times 10 all over 2 times 2. Okay, 9 plus or minus, I have 81 minus 80. So that's going to give me the square root of 1 over 4. So this one I'm going to actually be able to get a real solution for. So I have 9 plus 1 over 4 and 9 minus 1 over 4. So I have 10 over 4 or 5 over 2, and I have 8 over 4 or 2. So my solution set is 5 halves and 2. Okay. Let's try one more. 4y squared minus y plus 7 equals 0. So if I have this, then I have negative 1 plus or minus negative 1 squared minus 4 times 4 times 7 over 2 times 4. All right, so I have 1 plus or minus. I get a 1 minus 16 times 7. What do I get for 16 times 7? So 10 times 7 is 70, and 6 times 7 is 42. So that is 112, right? For AC. So I have minus 112. So 1 plus or minus the square root of 111, negative 111 over 8. Okay. I always check if this is going to be negative, and we're going to talk about that in 1.3 when I have a negative under there, and those complex numbers, you remember them as I. But I always check under here to make sure, could this simplify in any way? And remember, if it can't fit out of all 3, if I had 6 plus or minus the square root of 48 over 4. Let's just say I had worked a problem and this is how it come out. So that gives me 6 plus or minus 4 times the square root of 3 over 4. Well, 2 comes out of all of them, right? So I could take that and make it 3 plus or minus 2 square root of 3 over 2. That will simplify out of all of them. Make sure this doesn't reduce and that you can't get all 3 of them before you leave them. Sometimes, like, what if I had 9 plus or minus the square root of 48 over 4? Well, that would have reduced here, but because it doesn't go out of all 3 of them, then it cannot reduce at all. It is simplified. This would be your final answer. You can't reduce just part of it. It has to come out of all 3. All right, before I close this video, we're going to talk about the discriminants. Okay. The discriminant is just that part under the radical. Oops. The discriminant is just that section right up under the radical, that b squared minus 4ac. And what it tells you is how many solutions you'd have. Remember, I said when we're solving these, we're looking for those x-intercepts. So what this will tell you is how many solutions, and by solutions, we're talking about how many x-intercepts. How many times will my parabola cross the x-axis? So if this is positive, let me write b squared minus 4ac is positive, then you're going to have 2 real solutions. They might not be rational, but they will be two real solutions. In other words, your graph somewhere, somehow is going to cross that x-axis in two places. It doesn't tell you, it might be upside down, but it is going to come across that x-axis in two real places. If it is 0, let's say just this part right here comes out to equal a 0, then you are going to have one solution. That means that that parabola is going to touch that x-axis. Don't quite know how, don't quite know where, but it is just going to touch and go back. There is one solution, one x-intercept. Then the last thing is, if it is negative, then you have no real solutions. Doesn't mean you can't graph it, doesn't mean anything like that. It just means that your parabola will not touch the x-axis. It'll be above it, concave up, or it'll be below it, concave down. It's just saying there are no intercepts. Okay? All right, and that is all of the videos on solving quadratic equations from 1.2.